Today our lesson is on exponential models. Our objectives are compound models, Euler's number, and compound continuously. So where do we see exponential models in real life? There's three things that you're really familiar with: populations, money, and credit. All three of those different things you've seen with exponential models. So we actually use this in real life. Okay, the most commonly used model for compounding interest is this formula. Okay, so let's talk about each piece of this so we can understand exactly what this means. So first of all, this P, that's the principal, which just means how much money you start with. Your R is your rate, and it's always written as a percent in the word problem, but you have to make sure you turn it into a decimal. Never put it as a percent in this formula. You have to change it into a decimal. The N, there's two different places the N occurs in this formula, and the N just stands for the number of times an amount is compounded per year. So you're going to see in your word problems, it's going to be compounded annually. If it's annually, you're going to substitute 1 in for N in both of these places. If it's compounded semi-annually, you're going to write 2 in for these into both of those N's. If it's compounded quarterly, you're going to put a 4 in for N. Monthly is 12, weekly is 52, and 365 is yearly. T is the number, is time in years. Time in years. So those are the pieces of our formula. Now you see this plus or minus. Remember in the quadratic formula, we used both of them. We had, this side of the formula plus this side divided by, and then minus, and then we had two answers. In this formula, it's either or, okay? It's not both. So it's either plus or minus. So if we're going to use plus, it's because we're growing in value. And if we're going to use the subtraction, it's because we're depreciating or getting smaller in value. Okay? So again, principal is how much you start with. Rate is a percentage, but you write it as a decimal. N is the number of times an amount is compounded per year, so compounded monthly, weekly, yearly, so on. And then T is the time in years. We're going to make this a positive if it's growing in value and a negative if it's depreciating or getting smaller in value. So let's look at our first example. Amelia deposits $500 into an account that pays 4.3% interest, compounded annually. How much will Amelia have in 4 years? So this $500, that's what she starts with. So that's the principal, how much you start with. The rate, remember you have to write it as a decimal, but this is the rate here because it's always a percent. See how it says compounded annually? Then we know our N is going to be 1. And 4 years, that's our T, our time in years. So we already have all the pieces to fill in this formula. We're going to make it positive because we're talking about interest. Interest makes your money grow. So she deposits $500. At the end of 4 years, she's going to have more money than she did when she started with because of the interest. So we're going to put a plus sign in between 1 and R over N. So P is what she started with, $500. R is the percentage, which is 4.3, but we need to change that into a decimal. So remember when we change into a decimal from a percent, we move 2 places to the left. So we started with 4.3 and now it's 0.043 for the rate. Our N is annually, so that means 1. And T is 4 years. So now we just plug in. So we have P is 500. 1 plus 0.043, we always change the rate of a percent into a decimal. N is 1, so I plug in 1 here, and T is 4. So we're going to start with the parentheses. Now 1 plus, I'm going to divide this number first. So 0.043 divided by 1 is still 0.043. And then I'm going to multiply up here. 1 times 4 is 4. Always do this parentheses first. So 1 plus 0.043 is 1.043. The 500 just keeps coming down, and we're going to raise it to the 4th power. Now, we want to do exponents after we do parentheses. Remember PEMDAS, parentheses, and then exponents. So before we multiply, we have to do the exponent. That's really important. We have to do that piece first. So put this in your calculator and you're going to get this number. It's going to go on forever, but I just put it to 6 decimal places just to be safe. And then 500 times 1.1834. Okay, then you're going to round to the nearest hundredth. Why? Because we're talking about money. So it says, how much will Amelia have in 4 years? She's going to have $591.71 after 4.3% interest. Okay? And so the reason we round off to the nearest hundredth at the end is because it's money, and we can't have more decimal places than that. How much money will Amelia have if another account offers to compound monthly at 3.6% for 4 years? So we're changing the percentage to 3.6. Still T is 4. And now it's compounded monthly. So that means N is 12. So 500 still stays the same. It's still plus because we're talking about interest. And it's 0.036 this time because our percentage changed. Over 12. 12 because it's compounded monthly. Raised to the 12 times 4 because of 4 years. So divide this part first. So it's 500 times 1 plus. When you divide that, it's 0.003. And do this with me so you can practice putting on a calculator. Raised to the 48th power. So this piece right here is 1.003 to the 48th. And then put this in a calculator. Now, we always need to do that part first. So in your calculator, you're going to put 1.003. You're going to put the caret button, so raise to the 48th power, and then push enter. So put this in your calculator, 1.003, raise to the 48th, and then push enter, and you'll get this answer. 500 times that whole thing is $577.32. So that's your answer. So which one does she make more on? You would definitely want to put it in this account rather than this account because she does make more money. Okay, a new car valued at $20,000 depreciates or gets smaller at a rate of 9% annually. How much will the car be worth in 5 years? Again, we're going to be using this formula. We have to figure out if it's plus or minus. Well, depreciates means it's minus. And then we're going to define our different parts. So we have P equals, it started at $20,000. R is 0.09. Remember, we have to change the percent into a decimal. N is 1 because of the annually part of it. And T is 5 because of 5 years. Now just plug it into the formula. So 20,000 times 1 minus 0.09 over 1 raised to the 1 times 5. So let's do this part first. 0.09 divided by 1 is just 0.09. Keep everything else the same. 1 times 5 is 5. Now we're going to do what's inside the parentheses and then raise it to the exponent. So 0.91 raised to the 5. So 1 minus 0.09 is 0.91 raised to the 5th power. I'm going to do this first. So use the same strategy in your calculator. It's 0.91 raised to the 5th power. This is what you're going to get, and then you're going to multiply it by 20,000. So after 5 years, the car is only worth $12,480.64. Okay, the last thing I want to talk about is Euler's number. So Euler's number is about 2.72. This is going to come up in the rest of this unit as well. So the number has as much importance as pi equals 3.14 in math. If an amount is compounded continuously, so remember back on this page, it said compounded, and then it could be annually or monthly or yearly or whatever. Okay, it depreciates at a certain amount or it grows at a certain amount. When you're talking about compounding continuously, we use a different formula. It's A equals P times E raised to the RT. So this is the key word here, continuously. If you see compounded continuously, you know you're going to be using this formula instead. Okay, so PERT. That's how you think of it, PERT, P-E-R-T. P is the principal or the amount you started with. So same kind of concept. Rate is still R as a decimal. T is time in years. So we still have the same three pieces, but this E is actually a number. It's about 2.72. It goes on forever, just like 3.14 goes on forever. Okay, so let's look at an example. You deposit $7,000 into an account that pays 2% compounded continuously. That's when we know to use this formula. How much will you have in 6 years? Okay, so we're going to use this formula, and our P is 7,000. Principal, what you started with, 7,000. You're going to keep the E there, raise to the R, which is 0.02, times the time, which is 6 years. We're going to start here. So 0.02 times 6 is 0.12. And then okay, so don't multiply this first. You have to do this piece first, E to the 0.12, which is, now in your calculator, you're going to type in E. You're going to push raise to the power of 0.12 and then push enter. So try that. Make sure you get that same number and then push times 7,000. Don't clear it, put times 7,000, and that's what you should get. And I should have put a decimal right here. There we go. Okay. So your answer is $7,892.48.